energy levels or shells, and orbitals. Niels Bohr came up with a model of an atom that has the nucleus in the center, and orbiting the nucleus are electrons that go in specific orbits, and he described them as energy levels or shells. So the one closest to the nucleus here would be 1, then the one after it would be 2, and so on and so on. And he used this to understand why certain elements would display light when their electrons would get excited when the electron would jump from one energy level and go down to another energy level, and why specific types of light would come out, what would happen during a flame test, for example. But what we happen to discover is that electrons don't really move in a circular motion or orbit around the nucleus. What we notice is that they actually move in orbitals, a region of space. So the atomic orbital is the region of space around the nucleus in an atom in which there is a high probability of finding the electron. So that electron may move out of that region of space, but most likely we're going to find that electron there. There are four orbitals. There are orbitals with 4 sublevels. The S sublevel is the first one, and it can only fit 2 electrons. P is the second one. It has 6 electrons. It can fit 6 electrons. D can fit 10, and F can fit 14. Now, to describe an electron and where it's at, we use quantum numbers. A quantum number it's a number used when describing energy levels available to atoms and molecules. An electron in an atom or ion has 4 quantum numbers to describe its state. The principal, which describes the energy level, the angular one, which describes the energy sublevel, and we have the magnetic quantum number, which tells us which space where it is in the orbital in terms of space, and we also have the spin, so describing the spin of the electron. So all 4 quantum numbers help us identify an electron in an atom. Now, also to help us remember, what we need to know is that the Pauli exclusion principle, that no 2 electrons within an atom may have identical set of all 4 quantum numbers. So they all are acting differently in the atom, because these electrons can be at different energy levels, or can be in different orbitals, or can be spinning in different directions. And so because of this, we can tell pretty accurately and describe different electrons, even though we can't necessarily see them. And this helps us understand why we fill in the holes that Bohr left in his model, and this helps us describe electrons more easily and can help us understand why certain things happen when atoms are coming together to form bonds.